All right, it's time to begin our next session. If we could go ahead and have Charlie and not Charlie, I'm sorry, Ed and Renee and Dr. Zurbuchen go ahead and activate their microphones and pictures. We'll move forward. Great. Waiting for there's Dr. Z. If you would activate your unmute your. There you go, and here he comes. All right, all three, plus me, and I'll drop out in a moment. Now, this session is our VBExtra Science and Human Exploration, and it is exclusively and generously sponsored by the Aerospace Corporation. And here to introduce our speaker is Ed Swallow, the Senior Vice President of the Civil Systems Group. Ed, go ahead.
Thank you very much, and thank you for the opportunity to address the 13th Annual Wernher von Braun Memorial Symposium. As the only federally funded research and development center dedicated to ensuring the U.S. has the preeminent space enterprise, Aerospace is proud to sponsor this session of the symposium and support these important discussions about our shared vision for the future of space exploration, focusing on the symposium's main theme of turning vision into reality. I personally appreciate the opportunity to introduce the next discussion about science and human exploration, which are priority frontiers for our teams at Aerospace. We enjoy strong partnerships with both speakers on this panel, and we are privileged to observe and support their continued groundbreaking work through their respective NASA missions. The panelists will discuss the intersections and overlap of science and human exploration initiatives in planned and conceived missions. What science will be done on the moon, on Mars, and beyond? Who or what will do it? How will autonomous and human missions work together or separately to achieve a variety of scientific objectives? I'm not going to read the entire bios of the two speakers, but I want to give you a few highlights. Dr. Renee Weber is Chief Scientist of NASA's Marshall Space Flight Center's Planetary Science Group, specializing in planetary and lunar seismology. She was previously the manager of the Heliophysics and Planetary Science Division at Marshall. Dr. Weber's scientific research focuses on understanding planetary interiors, particularly as elucidated via seismology. She was a science team member on the Mars InSight mission and active in the planning for a lunar geophysical network. She's a transplanted California, originally from upstate New York, and we were talking earlier about the parallels there with myself. Although she earned a PhD in Earth Sciences at UC San Diego and her bachelor's degree in physics at Cal Berkeley. Dr. Thomas Zurbukin, Associate Administrator of the Science Mission Directorate at NASA headquarters. Dr. Z sets the NASA Science Mission Directorate strategy and oversees its execution to foster partnerships across disciplines with industry and internationally to advance the frontiers of knowledge and exploration. He has been a leader on scientific teams observing the Sun and Mercury and received multiple NASA awards. He's a former professor of space science and aerospace engineering at the University of Michigan, where he was also founding director of the Center for Entrepreneurship at the College of Engineering. He's originally from Switzerland. He earned a PhD and a master's degree in physics from the University of Bern and received that institution's leading science recognition, the Heinrich Greinacher Prize, in 2018. I once heard him use the phrase, the purpose of science is to push back the boundaries of ignorance, which I recently found attributed to one of my own heroes in electrical engineering, Michael Faraday. In researching this theme, I also found a quote from Einstein, who said, "Thoroughly conscious ignorance is the prelude to every real advance in science." In those terms, Thomas stands on the shoulders of giants and effectively pushing back the boundaries of ignorance. Please join me in welcoming Dr. Renee Weber and Dr. Thomas Zurbuchen. Thank you.
Thanks so much. I think what we're going to do, and I'm really looking forward to that, what we're going to do is between Renee and I, we're going to call each other out by the first names. We know what our degrees are. What we're going to do is just kind of have a chat together and really chat. I like that better than giving a talk. I think it's, especially in an evening, easier to listen to. But what I wanted to do is just give kind of three things up front. First of all, I wanted to add my congratulations to Dr. Michael Wernher for his award that he just received. I want to tell you, the TRAPPIST-1 story, which is a story, one of the early stories that I was glad to be part of, and I met him there for the first time in his role as the project scientist of Spitzer. That story, of course, was one of really finding a star with 7 Earth-based kind of rocky planets around it. I remember still the little press conference we did, and then I was living next to the museum, and I got up in the morning and looked at all the title pages from around the world, often, but also around the United States, and putting that important story on above the fold in so many cases. Yes, science, exploration have a tremendous power to change what we know, but more importantly, to change how we think. And it's the story about the potential of Earth-like planets elsewhere that, of course, the TRAPPIST story told us. And this is just one of many. Dr. Michael Werner was part of it, and I just really wanted to thank him for that. The second story that's happening right now that really, just like the one about TRAPPIST, really deals with the element of surprise. And I want to ask you whether you could put it up, Patrick, or whoever is on the controls, is of course related to OSIRIS-REx. I want to tell you how proud I am of the team, just like Michael Werner talked about, the important power of the team to do amazing things kind of over and above what's possible by any one of us. When we look at the mirror so often, we think of, we see a lot of deficiency, we see a lot of weaknesses, but what's amazing, and I think once you have experienced it, and many of you have, if you're part of a great team, you get addicted to that. A team that's much better than any one of us. For example, a team that can tag an asteroid that looks entirely different than it did. And next visual, please. Punch a hole into that thing that may be as deep as 50 centimeters. We're still trying to figure out, this kind of a cover that's now entirely black there, of course, was transparent. So there's a lot of sample behind it. And as they say, the cup runneth over. The cover is a little bit bent there at 9 o'clock. We talked about it during the week and Friday evening, in fact, during a little press conference. And I want to tell you how excited we are. We just announced that we're actually made a decision to stow. We already see, not in this visual, but others, that kind of the rocks that are there and actually keeping the diaphragm slightly open are by themselves close to 50% of the mass that is the requirement that is there. You see all the other kind of color there now, even though some of the samples have disappeared of specific shapes and so forth. Many of them are there, and we just couldn't be more excited. And that's want to congratulate this team. That's one of the stories we just pulled out. The other one, next slide, please, relates to our heavenly neighbor there, the moon. And, the moon is, a really good example for us of a storyline that has been with us. The moon, of course, is what dreams are made out of for millennia, for many of us, for us, kind of when we think about it. But what we announced today is actually kind of couple observations. The first one using the Sophia telescope, really looking at, if you want, the volume content of water, but on also in some of the areas, kind of through another paper, LRO, basically the some of these cold traps really holding water. We can't wait to go there. This is indicated here. We can't wait to go there and actually really see this. And frankly, we want to go land there. Initially with robot, and then of course with humans, because here's the issue. What we'd like to do, of course, we have remotely sensed the moon. Some of the best and most important things we've learned are from samples there, and we can't wait to get samples back from that polar region, a polar region, of course, that we want to land with astronauts that actually can get us the samples back. In addition to that, there's a next generation of instrument of the type that Renee is really excited about that we could put out there on the moon. And Renee, I've read your paper about really the interior of this celestial neighbor there. And I just wanted to, just before we launch into it, just wanted to just tell you how you saw the article today, that came out. What did you think about it? What's the most urgent thing you think we should be doing right now on the moon scientifically from the perspective of Renee Weber? Go ahead.
Well, that's a great question, Thomas. I think, fortunately, we already are doing the most important thing that we really should be doing to address high priority questions in lunar science, and that's going there. And of course, with the Artemis 3 mission, we're currently looking at what types of science investigations we can address on the lunar surface. And of course, with the news today of the observation of molecular water, that's a pretty important one, and one that hopefully we can sustain through future sample return and investigations in situ.
So, so you're somebody said earlier in your introduction, Ed, in fact, not somebody, Ed said in the introduction of you that you've focused on the interior of the moon. What's the most urgent thing you'd like to know about the interior of the moon that we don't know at this moment in time, that you think both human exploration and robotic exploration of the future could help us get?
Yeah, so sending geophysical instruments to the moon is one of my key science passions. And the moon's a pretty interesting place to do geophysical investigations, to look at the interior, because of the fact that it's considered an ancient body. And so it probably retains more of its initial formation characteristics than a planet like Earth, where those types of data and those properties of the interior are constantly being recycled by the action of plate tectonics. So understanding the internal structure of a planet is what helps really pin down the planet's formation and subsequent evolution through history up to the modern day. And we can use geophysical instruments to probe the deep structure of the moon and look at its layering, its crust, its mantle, its core, its chemical composition, the source regions for volcanic features and Mare volcanism that are observed on the near side, that ultimately play into the present day distribution of volatile elements, heat producing elements, and other sort of anomalous terrain on the moon. So it's all tied together in a way that's particularly interesting and particularly addressable by geophysics.
That's really cool. So it's just a huge opportunity, both with human exploration and robotic exploration. And of course, that during the last few years, we spent a really huge effort, and I hope it feels that way at Marshall. And frankly, I'm going to ask you about that. That we made a huge effort to really tell people that the difference between human and robotic exploration is merely one of bureaucracy, if you want. There's a directorate that does that. There's a directorate that does this, but they're very deeply related to the core. Some of the biggest successes in robotic exploration, and I'm thinking about the Hubble Space Telescope, in part was enabled, as you know, by astronauts that in fact fixed one of the blunders that happened in the robotic world, and did that. Another one, of course, and I may or may not have told you that story, Renee, is that where I actually got my PhD is an institute that was opened because of one of the experiments that stood on the moon. Buzz Aldrin set it up during Apollo 11, right? The solar wind experiment. There are many other stories like that across the field. Heliophysics, just to give one more, and of course Marshall is really strong in heliophysics with so many of the observations there, looking at the active sun and especially that transition between what is the photosphere, right? The calm, well, it's not calm, but that thing that looks pretty steady, to the very violent atmosphere, which we call the corona, right? So Marshall has really done breakthrough things, and heliophysics is basically, if you want, turning into the weather forecast for astronauts, right? Situational awareness for them. But so you work at Marshall, Renee. How does this science fit into a center that really has its, if you want, its proudest moments so often, and in the human exploration world? You're a scientist there. Tell me how you deal with that two-sided aspect of exploration with a capital E, so to say.
Sure. Yeah. I mean, a lot of the things that you were just talking about feed directly into this philosophy that you may have heard about science enabling exploration and exploration enabling science. And it's really a symbiotic relationship. And, you know, some of the first questions that we had to answer when we went to the moon during the Apollo era was, what is the moon like? Just fundamental discovery about the moon before we could even determine whether it was safe to send humans there. And that's just one way that science can really benefit exploration. You know, like you were mentioning earlier with heliophysics investigations, looking at understanding the drivers of solar energetic events that produce space weather. And space weather and the radiation environment in space are things that we have to be concerned about when we're sending humans both, you know, into low Earth orbit and beyond low Earth orbit in the cislunar environment, where we're moving outside of the Earth's protective magnetic field that deflects a lot of that space weather. So heliophysically, astrophysically, looking at high energy particles, again, radiation environment. In planetary science, we're really focusing on understanding the surfaces of these bodies. In particular, on the moon, you know, we're looking here at Marshall with the Human Landing System program, and we've got scientists plugged into that program, helping with environment definition for the lunar surface, looking at risks to astronauts, looking at dust, the dust environment and different hazards, you know, monitoring the meteoroid environment in cislunar space and looking at meteorite impacts. We've got a group that does atmosphere modeling, not so much an issue on the moon, but maintaining these global reference atmosphere models that help to do entry, descent, and landing when we're looking at sending both human and robot missions to other planets that have atmospheres. That's an area where Marshall is doing work, and really just the sort of the fundamental science that feeds into those activities. So Marshall is a center that I think is uniquely situated to help provide this type of expertise to these human exploration programs.
So I'm really interested in your view on this. You know, so if I observed during time and as a scientist that so many of the lunar science kind of experts were, you know, people that were trained during the Apollo era. And I look today at the lunar community, it's a very different community, huge vitality with, you know, of course, that wisdom of those tremendous experts, you know, and some of them are my closest friends, right? But I just wanted you to, I mean, how would you, like, yeah, I'm sure you give talks to encourage others, you know, what's the kind of encouragement you would give somebody to really look at the moon as a target to do exciting science? Why would the moon be such an important part of kind of really understanding our solar system, our Earth itself, and so forth? How do you pitch it? Like, what's exciting about the moon today?
Yeah, so personally, I find the moon exciting because it's right there. One of the things I always say to myself when I walk outside at night and look at the moon is say, it's right there. It's so close. I'm really looking forward to getting up there. But like I mentioned earlier, scientifically, the moon is a very interesting place to study if you are trying to understand the solar system, the origin of the planets, particularly the terrestrial planets, but also even the same types of processes that govern the formation of planets in other solar systems, exoplanets. You know, we've discovered a lot of terrestrial rocky exoplanets, which probably underwent very similar formation conditions to our own solar system. And by going to the moon and by bringing back samples, by doing science in situ, and by deploying long-lived instruments, we can address those types of sort of fundamental planetary science questions. So the moon is a very enticing place, and I hope to communicate that as broadly as I can.
So, you know, we just started a decadal survey in planetary science. And what's really unique about this one is compared to previous ones, we actually think within the next decade, there are planetary targets that are assessed by humans, right? Kind of in a way that, frankly, robots cannot. So, like, if you were kind of just, you know, not institutionally, but you as a, you know, researcher in this field, like, were to prioritize, what do you think are the most urgent things that humans should do on the surface of the moon that really would be very hard to do or impossible to do, in fact, almost impossible, at least, with robots. How would you prioritize that if you were king for a day, or queen, I guess, for a day? Yeah.
So I'm actually working with the Artemis 3 science definition team that is actively attempting to address that exact topic right now. And fortunately, the past 50 years of science, lunar science research since Apollo has provided plenty of sort of strategic guiding documents to help point out exactly what the highest priority science questions are. And the decadal survey is another great example of a place where we can kind of list and review those outstanding questions and help prioritize future missions. But when you're looking at the difference between human exploration and robotic exploration, yes, a human is capable of sort of in the moment decision making. It's a lot more difficult to do. One example to do robotically, and one example I'll give is the Mars InSight mission. So I don't know how many folks are up to date with the status of the Mars InSight mission, but one of the instruments on the InSight mission was a heat flow probe that was designed to hammer itself down beneath the surface. And unfortunately, for reasons that we still don't know exactly why, it has not been able to hammer itself down as deeply as it could. And of course, from Earth, communicating robotically with the lander on Mars, it's a very difficult problem to try to troubleshoot. And as an example of something that a human would be able to resolve almost instantly. Well, I've encountered some kind of obstacle right here, so I'll just pick my instrument up and move it a couple feet and try right here. And so that kind of real-time decision-making and real-time troubleshooting is an example of ways that humans can address things to make more efficient use of time. And time is a valuable resource when it comes to planetary exploration.
Yeah. So if you ask me the same question, kind of what I would have said is, and I want your reaction to it, is like the most important thing we really want is to understand, get samples back here that come from that region that I showed, both in the story that we talked about today, but also just because, frankly, we want to go there with humans. We want to see what the resources are that are there. In what way is it useful? How is the water in that rock, right? Frankly, when I went to school, and I hate to admit it, but it was like early 90s, right? Talking about this water and the moon were never used in the same word, right? And, so in the same sentence, that is. And, so that's one issue. The whole volatile cycles is the second one. And you mentioned already that there's questions about volatiles both on the interior of the moon and its history and but also on the surface, like where these water cycles, some of them from the solar wind interacting, you mentioned that before, but also other, that volatile cycle. And the third one I just want to talk to you about is one that I'm really excited about, and I see that already now, and that is that in many ways, the moon is becoming a platform for advanced instrumentation, the likes of which we really haven't seen because of the commercial partnerships. And perhaps we talk a little bit more about that, but that we're doing is that the moon is becoming way more accessible. And so basically our promise is to do that. You always celebrate when you're landed and you clap when the instrument is on, not a minute before, right? I know enough of that. I've built my own things and sweat it. And with it, and all tears and everything that goes with building hardware. But for me, what I see is exciting instruments, both in astrophysics. The administrator talked eloquently about emissions of the early universe, the dark ages from the far side, when the Earth, which is a big radio emitter, is blocked off by the moon itself, and so is the sun, which is a ginormous radio emitter, right? And so, but anything from that to space weather to planetary instruments, that platform for advanced breakthrough instrumentation is really what is exciting me, besides the volatile cycle and getting the probes back, because those samples are just absolutely crucial. But I kick it back to you. I was just, what did I miss? What's the most important mission that you see?
Well, you talked really briefly about the commercial program, and NASA has the commercial lunar payload service program. Ooh, that's a mouthful. The CLIPS program, which will use these commercially provided small robotic landers to bring science payloads to the moon in the immediate future. I think the first mission will launch next year. Marshall is just one of many centers and academic institutions that is actually providing science payloads. And so I'm curious, what can we learn from this commercial paradigm, and how is this going to benefit both lunar and planetary science in general going forward, and science just beyond planetary, but encapsulating all of the divisions of SMD?
Yeah, I really agree with that. I think, it's in the middle of an experiment, right? If we, I get now pictures of hardware and of, reports of successful test results for so many of these, and I see the instruments being delivered, finalized, whether they're from Marshall or from other centers, from companies, from universities, they're moving forward, right? And frankly, I'm just impressed by the sheer magnitude of innovation of some of these things, and some of them are frankly the first ever measurement of radio emission near the lunar surface. That's one of the experiments that's going. It's like, wow, I immediately want to ask 10 questions, right? Because all the plasma interface with that, neutral surface with the plasma going on it. I used to teach classes on kind of waves that get emitted there. Of course, our astronauts that were there have told us about the the dust, that electric field effects that were clearly visible, and all of this is of course deeply relevant to situational awareness for astronauts. Is there anything else that we should talk about before we kind of open it up for questions, Renee?
Let me ask one last thing, and this is a question focusing on diversity. So we know that diversity has been an especially important topic for 2020, and you've expressed the importance of diverse thinking in our approach to science. And so what I want to ask is, how is SMD and how can we ensure that we're broadening our footprint of discovery to non-traditional avenues for scientific discovery, encompassing more diverse values?
So let me just tell you how I've thought about this. And Ed introduced me as the guy who started the entrepreneurship program. And frankly, I spent a lot of time working with scholars of innovation, but also with practitioners of innovation. And if you really ask them, what are the key ingredients to really an innovative team, a team that kind of making history, what they will tell you is the team needs to be composed of people who are not alike. Right. So it's kind of, we've had that experience. It's actually a lot harder to build a team in which people are there with very different backgrounds, because frankly, when I say something, I may offend you without even meaning to, right? It's kind of, I'm, my strength and my weakness are I'm direct, right? And not everybody, thinks equally positively about that. You may, or somebody may have different, different elements. So for me, when I look at context of diversity, I think of it through the viewpoint of the excellence of teams. I'm going to tell you that's one of the viewpoints that is really critical. Frankly, that's what I mostly jumped on right away. And I just want to tell you, I was in a number of meetings, even in our valued organization, NASA, and so forth, where I just really felt like, if somebody was there of my psychologist friends, they would have identified group thinking like very simple way. And it's like, I'm like, that's not excellence, right? We need to really have the right discussion and struggle through it. So we need other viewpoints. I think the other thing I want to tell you also is, I'm a first to graduate from my entire town in college, right? I'm the first in my family, I'm a father of a daughter, so for me, it's like, why wouldn't people like me, people, I really, met so many people who are from both inner cities, but also from rural areas, mining country in Michigan, where I was on the board of a university. I want those people to be part of that. They're super hard workers, just absolutely amazing people, and we don't want to leave them on the outside. For us, it's really critical to do that. So for me, opening doors, people open doors for me, and I'm grateful to those people all the time. So for me, it's always been just a something I want to do. And I'm so glad that others feel the same way. Ultimately, it's clear, and if you've had the experience, it's clear whether you talk to a group of students or me, you know, with my accent, just the way I look, how old I am, we have a different impact on inspiration. So that's another element. You know, if we want to inspire, the who matters. It's not just the what, the message and the story. So for me, those are the three motivations. Again, team excellence, opening the doors, and really inspiration, kind of turning on inspiration to the best we can. Does that make sense? So let's see whether there's any questions. I don't know how questions will be fed into this, but I'll just stop and see whether you have any that you receive, or whether somebody wants to drive some questions into us.
This is Alan, and we have just a moment or two, so I'm going to direct one at each of you. The first one is for you, Thomas, and that is these discoveries or these expeditions that we're doing now seem to come in waves. We had the wave of things happening with lunar maybe beginning with Clementine, and then lots of people wanted to go to the moon. Now we've had, in the recent history, three direct encounters of asteroids. You've got the Rosetta, and then Halevisu, and then the OSIRIS-REx. Why do you think these things come in waves like that? And what do you think is the next wave that's going to bring us some kind of significant surprise like we've received in the past two?
So I love that question, just because I think about it a lot, right? So for me, you know, kind of let's call it the small bodies. Sometimes people call them, or the primitive bodies. If you talk about it from a kind of solar system history perspective, and of course, Renee can add a lot to that. But you know, their comets and asteroids are really critical bearers of information that kind of give us about history about the Earth and the solar system, the moon of our history. And so basically what happens, I think, is there's two things that can open a wave like this. The first one is a science question that becomes urgent. We just talked about one of them at the moon, volatiles. It's kind of things that shouldn't be there, like water, like other volatiles that are there. You know, it's like, well, we need to know, like, it's entirely different than what we expected. I think there's similar type of questions. The complexity of chemicals in these, what they're called primitive bodies, are by orders of magnitude higher than we ever thought. Now we think of those bodies perhaps as seed bodies to seed life on Earth. That's not something that anybody talked about 20 years ago. I think a wave that's happening right now, and it's just at the beginning, is really one that is focused on astrobiology. So it's really missions that are focused on kind of the environment of life elsewhere and finding life elsewhere. Those are missions that we're now ready for, both Mars sample return at Mars, Dragonfly to go to Titan, but there's other missions, including exoplanet missions, that go in that direction. And just to give one of those waves, I think that will be what I believe is starting right now, but we haven't even seen the peak of that yet. That's how I would have answered, Alan. Back to you.
All right, thank you. The cause of those things tend to defy me, but I really don't work in those environments as much as probably I should. And that leads me to the next question for Renee. If we look at this kind of like economics, macro versus micro, Thomas is the macro science guy. He goes off and he's running the entire big program and worrying about the direction of the big program. And you're the micro economics person or the micro science, and you've got responsibilities to go off and to implement and to advise and to influence the macro. How do the folks in your position maintain interest and maintain excitement in the rest of the center, in the rest of your environment there, your research environment with the different universities you have, the different companies you have around Marshall? How do you maintain their interest and help them recognize that Marshall is a lot more than just a rocket producing center?
That's a great question. And that is something that strategically we are actively pursuing at Marshall. Just like external to the center, in support of agency exploration efforts, we try to provide a science benefit. we do the exact same thing within the science and technology programs that we maintain here at Marshall. And we've done that in a number of ways, both by, sort of actively supporting project scientists. We've got a sort of an informal brown bag seminar that we do where we encourage folks from the engineering directorate and folks from the science directorate to sit down together and talk about the projects and the programs that they work on and exchange ideas and just get the juices flowing that make those kinds of innovative discoveries happen. So that is an area that's very near and dear to my heart and something that I try to embody in my role at Marshall every day.
All right, well, thank you very much. And thank both of you for coming in. And Ed, thank you for being our sponsor for this last session of the day. It's been a pretty exciting day, pretty interesting. As we've gone through some different things that we normally don't usually see in the Von Braun Symposium. So thank you both very much.
Thank you.
Thanks, Renee. Really enjoyed that. It was fun.
Yep.
All right, and we'd like to thank our day one sponsors, the Aerospace Corporation, Blue Origin, and Boeing. And thanks to all of our sponsors, again, Aerojet Rocketdyne, Aerospace, Blue Origin, the Boeing Company, VBEx Technologies, Jacobs, KBR, Lockheed Martin, Maxar, Northrop Grumman, Teledyne Brown Engineering, not University, although sometimes you might think that, Teledyne Brown Engineering, University of Tennessee Space Institute, University of Alabama in Huntsville, and our media sponsor, Space News. We'll see you all again tomorrow at 11 a.m. Central, 12 p.m. Eastern for another great day, starting with an update on the international collaboration effort for the Moon 2024. And one more shameless plug. If you go into your session listing and go over to the left side and go down and pick up the posters, please go in and look at the student posters and make your vote for the most popular student poster that's been submitted for this conference. We are going to be giving the winner, the one getting the most votes, all expense paid. Well, maybe not all expense paid, but and all points paid trip to one of our AAS symposia in 2021. So that's it. Thank you and have a good evening.